With the logic in place to let the player change an object's material, time to get the blueprint making the actual material switch. Inside the content browser then, we want to double click so as to open up the SM_map_change static mesh actor and gain access to its graph if we are not there already. We can then right click in some empty space, type the word custom into the search, and then click to add a custom event, calling it change mat. Custom events are a very versatile way of building a small bit of blueprint code that we can then get another blueprint to execute. Now this can help us avoid having ridiculously long chains of nodes that are notoriously difficult to debug or change should the need arise. Compartmentalizing where we can then is going to be a big help to both ourselves and the project in the long run. Let's then drag from the change mat output, search for and add a branch node, and then, after dragging out the CanUse variable and selecting the get option, we can pipe that into the newly created branch node's condition input. Here is where we use the Boolean variable to see if the player can actually change the actor's material. And so, after this is done, let's drag from the true output of the branch node, search for and add a flip-flop node, and then drag out a reference for our SMChair LP static mesh and place it inside the graph. We are using a flip-flop node here because we are simply alternating between two different materials. If we are feeling adventurous though, we could expand on the number of materials in the mix by using other nodes instead, maybe trying arrays or sequence nodes to achieve this. Of course, one of the challenges of blueprints is that sometimes what seems like a simple solution to implement actually creates conflicts with other parts of the blueprint, and so experimentation will definitely be needed. Let's set up the material changes themselves then by dragging from the SMChair LP reference, and then searching for and adding two set material nodes. Making sure that we select the fabric white material for the first node, and then the fabric green material for the second. We can then hook up the flip-flop A execution to the first set material, and then the B execution to the second set material node. Here, the set material node can be told specifically what materials to change to, and so we could have stored the materials inside a variable and then use that to control the change. As we only have two materials though, selecting them manually isn't a problem. We just need to make sure that the material not applied by default occupies the first change in the flip-flop node. Otherwise, it could look as if the blueprint isn't actually working the first time that the client presses the mouse, given that the object would essentially switch to the material that is already applied. We are almost done with the setup here, and so it is time now to put our custom event to use. Inside our first-person character blueprint, if we come to the line trace graph that we created earlier, we can drag out from the branch node's true output here, and then search for and add a sequence node. We need to augment the blueprint flow so as to accommodate for the fact that we are already using this line trace to affect the light switches. We don't want to break that, of course, but at the same time, we don't want to have to create an entirely new flow just for this one blueprint. Sequence nodes then let us run through blueprint code one blueprint after another. If it attempts to run a blueprint but is stopped, it simply moves on to the next in the sequence, which is exactly what we need to do. And so, with the then0 output connected to the cast to BP light switch node, which will ensure that our light switch blueprint remains unaffected, we can drag from the then01 output, type cast to SM underscore, and then click on the SM map change entry that we see in the list. We then want to pipe the break hit result hit actor output into the object input of the cast2 node. Here, we are creating really the same setup as found on our light switch, in that we are getting the line trace to cast to the actor that it has hit, so that it can then tell whether or not this is the object that we want to communicate with, our chair, and then, if yes, execute the custom event that we have made. Let's do that then by finally dragging from the cast2 smChangeMat node's output and searching for the words ChangeMat, after which we can click to add the custom event that we created. We can then pipe the cast2 node's object reference into the ChangeMat node's target input, essentially telling the chair blueprint to run the custom event that we have created and so flip-flop between the two material types. And what we have seen here then is how to create yet another custom event, this time aimed at materials, using our Boolean variables to ensure a stable and working system. We have also seen how sequence nodes can be used to add flexibility to an already created blueprint that may be being used to affect a completely different actor in the level.